Hello everyone, in this video we are going to solve the problem number 1.77 from Irodov, and that is related to dynamics. So let us first understand the problem and then we will solve the problem step by step. So here we have this particular arrangement in which we have rod A and wedge B, and we need to determine the accelerations of rod and wedge. It is given that the mass of B, that is mass of wedge to mass of rod, is equal to eta, and there are no frictions between the contact surfaces. Okay, so because of the gravity of the rod will move in this particular direction, and as the rod will push this particular wedge, the wedge will move in the forward direction. So in order to find the accelerations, let us draw the free body diagram of rod and wedge. So let us first draw the free body diagram of rod. So this is A. Let us assume that the mass of this particular rod is m into A. So the gravitational force on this rod will be m times A into G. So this is the gravitational force that is acting on this particular rod, and we will have the normal reaction of N1 and N2 because of these two surfaces, and we will have the normal force from wedge on this particular surface. So let us call it as N. And now this particular inclined surface is making an angle of alpha with the horizontal. Now let's consider this as a x direction and this as a y direction. So if we just look at in this particular triangle, so if this particular angle is alpha, this is 90 degree, and then this will be 90 minus alpha, and the normal force will make an angle of 90 degree with this inclined plane. So if this angle is 90 minus alpha, then this angle will be alpha, and this is 90 degree, so this angle will be 90 minus alpha. So if this angle is 90 minus alpha, and if we take the component of this normal reaction in the x direction and the y direction, then we will have in the x direction, that is n times cos of 90 minus alpha, and in the y direction we will have the component that is n times sine of 90 minus alpha. So we can write this as n times cos of alpha, and here we can write n times sine of alpha. Okay, and if we can like balance the forces in the horizontal and the vertical direction, in the horizontal direction we can directly write that is n1 minus n2 minus n times sine alpha is equal to 0. In this expression there is no acceleration involved, so like this is not the use of it, and then this particular body is moving in the downward direction with the acceleration of aa. So we can write ma into g minus n times cos alpha is equal to mass of a into acceleration of a. So this is our first equation corresponding to the FBD of rod A. Now let us draw the free body diagram of wedge. So this is wedge B. From the ground we will have the normal reaction, let's call it as N3, and we will have the gravitational force that is mb into g, and from the rod A, this particular surface, we will have the same normal force that is N, and that will be perpendicular to this inclined surface which is making an angle of alpha with the horizontal, and this is x direction and this is y direction. If this particular angle is alpha, let us extend this a bit, then here this particular angle will be 90 minus alpha because this is 90 degree, and this particular angle will be alpha if this is 90 minus alpha because normal force will be making an angle of 90 degree with this inclined plane. So if this angle is alpha, this is normal, so this is basically alpha. So this component will be n cos alpha, and this component is n sin alpha, and the wedge is moving in the horizontal direction with the acceleration of AB. So we can write n sin alpha is equal to mass of B into acceleration of B. So this is the second equation we are having, and we are having one more equation, that is mb upon ma is equal to eta. So from here we can write mb is equal to eta times ma. So this is our third equation, but these three equations are not sufficient to solve the problem. We need one more equation related to the accelerations of rod and wedge, because the rod is pushing the wedge so that the wedge is moving in this direction. So this is acceleration of A and acceleration of B. So we need to form the kinematic diagram for this. We know that kinematic diagram is basically the vector diagram of the displacement, velocity and the acceleration. Here our interest is only acceleration. So this is the acceleration of A. We have the acceleration of B in the horizontal direction. So this is acceleration of A with respect to B, and this particular angle is alpha. So from this triangle we can write tan of alpha is equal to acceleration of A upon acceleration of B. So we can write acceleration of A is equal to AB times tan alpha. Okay, so this is the fourth equation we are having. Let us substitute the value of acceleration of A in this particular equation. So first equation will become ma into g minus n times cos alpha is equal to ma times ab tan alpha. Okay, and the second equation we are having n sin alpha is equal to mb into ab. Okay, this is basically second equation. Now we need to n from both the expressions, so we can write n is equal to mbab divided by sin alpha. So let us substitute this in this particular equation. So we will get ma into g minus mb into ab divided by sin alpha into cos of alpha is equal to ma into ab into tan alpha. Cos alpha divided by sin alpha is basically cot alpha, so we can write mag minus mb into ab cot alpha is equal to ma ab tan alpha. We know mb by ma is equal to eta, so let us divide the entire equation with ma. So we will get g minus eta ab cot alpha is equal to ab tan alpha. Okay, so from here we can write g is equal to ab times tan alpha plus eta times cot alpha. So from here we can get acceleration of wedge is equal to g divided by tan alpha plus eta times cot alpha. So this is the value of acceleration we got, that is for wedge. Now let us determine the acceleration for rod. So we have obtained acceleration of A is equal to acceleration of B into tan alpha. So from here we can get acceleration of A is equal to g tan alpha whole divided by tan alpha plus eta times cot alpha. So if we divide this particular expression by tan alpha in the numerator and denominator, so we will get g divided by 1 plus eta times cot alpha by tan alpha is basically cot square alpha. So this is the expression we have for the rod. I hope the entire problem is clear. Thank you.